Yeah.
Yeah, things here are sort of gradually getting back to. I think
Okay,
now they're just
let's
sort
get
of ticking.
going.
Yep.
Yep. So any progress from
I'm
you,
not sure.
Steve or Jack?
I'm not sure we'd call it progress, but I've been working on it. Yeah, so I'll just share my screen and show you what I've been doing. Yeah, so like I'd been working on the VAR one.
Right.
So yeah, so like the way I'd been tackling the problem was trying to predict the sort of the price ratios or whatever, which then let me calculate the target. And so because of the fact the price ratios lag by 16 time steps or whatever, so the end of the training data is missing 16. So these are my graphs for like the 16 predictions. And so like I thought that these were reasonably good, like yellow's my prediction and blue's the actual one for each of the coins. So like, and it sort of follows it along not too bad. And then like after those, then I sort of predict for the entire test set, which so these were my predictions here, which again didn't look too bad, but I'm not sure if you can notice.
Pretty good.
Yeah, they look pretty good, but if you notice, basically all they are is just like lagged. Basically, they're just copies of the real prices, but slightly delayed. And so, so like actually when you sort of predict the targets, I end up again like with a negative score. That's the score I get from this. And here's like the predictions over like the whole of the competition test set. So you can see like the blue one's the real one, the yellow one's the predicted. And it's a good prediction, but it's just like lagged by 16 or whatever. And so the score was rubbish. So I just, in frustration, I decided to give up on VAR. And so like I thought I would go and like have a look at what people have been doing in the actual competition and like the notebooks that are in the competition. So yeah. So like
by the way, do you, unrelated, do you use VS Code to manage these notebooks, or a notebook, or that's just something that?
Yeah, like this is all VS Code. So yes, like I downloaded the data onto my own PC. I don't have a GPU or whatever, but because of the fact VAR doesn't need it, like it's just like a lot quicker to run. And like when you're running like Jupyter notebooks as well, if I just like pause my computer, I can come back right back to like the cell I was in before, and like all the data is still loaded into memory or whatever. So it's like a lot quicker to get started when you come back to it.
Yeah, cool. I haven't, I use VS Code too, but I haven't used it to run notebooks. That's why I asked, is the interface pretty good? The IDE pretty good for?
Yeah, no, like they've been working on it. Yeah, maybe 6 months ago or something. It was a bit rubbish. It was a bit flaky, and half the time it wouldn't open the Jupyter notebook. But yeah, like it's like getting better every release. So yeah, like now Jupyter notebooks within VS Code all works perfectly fine. Yeah, it's
Steve, see with these plots, are these the closing prices?
No, this is that's the target price. Or sorry, the target
So
value.
do you think you're getting a negative score because of the lag?
Yeah.
Can you not manually sort of adjust for it? Because you're getting very good agreement in terms of the pattern, right? The variation.
Well, yeah. So like say like at this point here in time, so like the blue one is like the true target value. But at this point here, my network is predicting here, up above it. So because of the fact, like when you're like doing your submission, you need to say what value you have at that point in time. This point here, which is further along and like it's a really good prediction, it hasn't been predicted yet, so I can't sort of roll it back. this prediction doesn't come until whatever that is. What's that? A few minutes later, like a few time steps later. So it hasn't been made yet. Like if it was to sort of draw all of this graph, then I could push it back. But because I haven't sort of got the further bits yet, I can't push it back.
One question, Steve. So the VAR thing you're using, does that have this, in the ARIMA, there's also the moving average instead of just the, whatever, the autoregressive part? And is it the case that this one, if you include the MA part, then it would account for kind of this lag thing that you're seeing?
It might do. I don't know enough about, like as you say, like you've got like ARIMA, which is the moving average, and you can get VARMA, which has a moving average, but this is just VAR, so it doesn't have the MA bit. So perhaps if I did use that one, then it might be better. But
yeah, if your infrastructure is set up to just change VAR to VARMA, then you may want to just shoot off that job to see whether because if it's a moving average, I'm just thinking aloud, I don't know this for a fact, but is it the case that the moving average kind of helps you avoid this lag phenomena that you're seeing? Otherwise, as it looks really good. So if the moving average can somehow make up for just a sheer lag, then maybe that helps. I don't know. I mean, if your infrastructure is set up, then it's just firing off a VARMA job thing.
Yeah, the reason I didn't run that was because of the fact that, so here when it runs, it's recreating like the VAR every time step. So I think this function here, price is new.
Oh yeah, you do that to get the new data from the 16 every time.
Yeah, so effectively I get the new data every time, and then I like effectively retrain the VAR every time step with the new data.
Right.
So you can see here, like it fits it every single time step, and this is quick. This is quick and it works. And when I tried to use VARMA with the moving average bit, it was a lot slower, and so like it would run out of time. So like that's why I hadn't used it. But
interesting. Okay, I get it.
But
how long is the lag at the moment? Then do you know?
I'm not sure. It's probably 16 time steps, I would reckon. Like, what's that? There's 12 o'clock. Yeah, I reckon it's going to be 16 time steps. But
okay.
Might not be, but something like that. Yeah, but anyway, so I got fed up with that. So like I went to have a look at the notebooks that are in the competition itself. Effectively, there's like 3 types of notebook that are in there at the minute. So I was like sorting them by, like here, if I just go to the code for the competition. So there's like loads of, don't know why I've not done that. Yeah, so if you go, these are all the notebooks that have been submitted for the competition. So if you sort these by best score, so like you get absolutely loads of them are very, very close to 1. And like these are ones where basically all they've done is stick as their submissions the actual prices for the actual target scores for the public test set, because of the fact they have those. Then there's like another load once you go down below these ones that got 1 or close to 1. Then you start getting scores like these, like the 0.75s and 0.69s and stuff. So I thought like these look pretty good, but it turns out what these are doing, so they're not taking the target values directly, and they are like, for example, like this one here, I purchased Bitcoin. In this here, like he's using was it XG Boost or something, or like Boost Light Boost or whatever, but he's included in his training set, he's included the set of the data, which is the public test set data. And so like all these ones about 0.7, they've all got data leakage. Like, and this guy here, he was going, oh, like, this is brilliant. Like, the more I train it, the better it gets. And like the reason for that is because of the fact it's just fitting more and more onto the public test set. And like then within the discussions, yeah, people are on about it. And effectively the only notebooks in here that haven't included the things are ones with scores like this. And even that looks pretty good. Yeah, so
by the public test set, do you mean just the data in the test.csv at the moment?
No, I mean, yes, like this public leaderboard. So like at the minute, you've got the training data with the training.csv. The end of the training.csv is the data that they use on this public leaderboard.
Oh, okay. So how much of the end? I mean,
I think it's like 3 months, isn't it? So like I think
3 months,
minute,
okay.
The last 3 months from 6/20 or 21, 6/21/21 to 9/21/21.
Yeah.
Because, and the reason they do the 3 months is because when you eventually predict in the competition, they're going to evaluate you over 3 months.
Yeah. Okay,
yeah. So like,
sense.
so I found like this notebook, like this notebook is sort of as simple as you can get. It's really easy. So all it does is like it loads in the data. And yeah, somewhere around here. Yeah, so like this one here, this was like sort of one of the few I could find where it is just using before the public leaderboard. So you can see here, like he's removing all the data before the 13th of June, 21. And so like with this one,
in fact, you know, Steve, sorry to interject, but the one of the guys, and in fact, you know, the extra data guy that you were using, the extra data, or the guy who loaded all the extra data directly from some Coinbase or something, right? Where all that guy and another guy kind of pointed to something which said, oh, if, you know, let's take a strict equal true flag. And if that strict equal true, everybody would practice, then it would mean that you exclude this 3 months, like you're pointing out here. And that would help ensure that you're not playing this leakage game and winning that way.
Yeah, unfortunately, I think only about 2 or 3 people stuck with that. So most people haven't bothered. So it's hard to know, like without actually looking at their code, you can't see if they've excluded like the public leaderboard training data.
Oh, yeah, I didn't do it because I didn't understand what was going on.
Yeah.
Till now.
Yeah, so like if you've included all of the training set, then you'll be getting a much better public leaderboard score than you should really, because of the fact it's just training on the data that's used to evaluate it.
Okay.
But yeah, so like anyway, within this notebook, it's really simple. So he does exclude the public leaderboard training data. And here he uses like this LGBM regressor thing. And all he's doing is he's predicting directly onto the target values, like he's using target as his Y.
Yeah.
And yeah, so
I
like
did that with my early notebooks. The thing is he using the per second data for all of the training data except the last 3 months?
That's right, yeah.
Okay.
Yeah, so he does that. But you can see here, I don't know much about boosting regressors or whatever, but this number's I suppose really low. And like anyway, like when you run this and you could get a score. Yeah, so I ran this and you get this score, 0.0179, which according to like the discussion thing is like sort of half reasonable. Like if you're getting anything sort of positive at all, like people are reckoning that people are going to win the competition with maybe 0.1. These two above, these 0.7s, these are ones where it's got like data leakage. So like this is my best score, which would sort of actually stand a chance of doing anything. But then
okay, actually the the very early on what you had pointed to, that guy was just queuing notebooks right and left of the various methods.
Yeah.
That guy has an excellent LGBM starter kind of notebook too, which in fact has pointers to all the different, to the website or basically a blog, or I forget now what it was, but it explains all the different LGBM parameters that you can play with. And then, he also has this thing, I think I've never used it, but this thing I think called Optuna, where you can do the hyperparameter tuning. And he has one with the Optuna and the LGBM, that combination, so you can play with the hyperparameters of the LGBM things like what you pointed to, where essentially LGBM is, underlying it, you could use models, and then it just gradient boosts based on each model's errors. It just kind of subsequently adjusts the model to fit the error, and it goes from there, thereby boosting the fit each time by reducing the error from the previous attempt. That's conceptually what it does.
Right. Yeah, so like anyway, I tried it like locally. So like this was running it locally. So like here it's like the 10 estimators. And yeah, like, so that gave me exactly the same score as I got in the public leaderboard. But I actually, so like and those other notebooks I'd showed you, which were getting sort of 0.7s, I thought I would like try them. They use like much more powerful LGBMs or whatever. So like here's like one of them. So like they massively increase the number of estimators and the number of leaves and play about with the learning rate. But they actually got worse scores. So like here was like 500 estimators, and it was slightly worse than having 10 estimators. And similarly, like when it got increased more, the score got worse. And yeah, so like I actually like drew a graph of what it was predicting. So this is this. So this one here is like one with whatever that was, a thousand estimators, say. And you can see here, like the yellow line is the prediction and the blue line is like the true target. So you can see it's underestimating pretty much. It's like sort of pretty much a flat line with like the odd spike in it. When you draw this graph for the 10 estimators, like the really low number of estimators, the line is pretty much all flat. There's no peaks at all. And so like it appears like that's how he's managing to get a positive score, because of the fact he's effectively not predicting anything. He's like sort of like minor variations around zero. And so yeah, like although like it gives you a positive score and it's probably the best score I've had, in terms of actually predicting anything, I don't think it's doing anything at all.
How much did you get? Sorry, that were able to get a better than the 0.0?
So now this is the best score I've had so far, like this 0.179 with, as I say though, that's with 10 estimators, and yeah, like effectively it just estimates the target to be 0 every single time, but like it does give you a very slightly positive score, even though it's not really predicting anything. Yeah, so where I am now is I didn't really know what booster things were, and so I went away and yeah, like in the Fast AI book that they brought out, there's a chapter on decision trees and forests and stuff.
Right. Actually, Steve, if you're looking into LGBM, the best place to, I'll post some links, but the best place to easily get up to speed on just what it does is the hands-on machine learning book that covers the basics of gradient boosting machines, and then the L and the varieties of it. I think I posted like different pointers early in our discussion of there's like LGBM, and which is the light GBM, and then there is variations whose names I forget now, but
yeah. Yeah, so anyway, as I say, I thought I would go back to basics, and yeah, like within Jeremy Howard's book or whatever, he's got like a whole chapter on sort of predicting on tabular data. And yeah, like
Yes.
starting with decision trees and like then random forests, and I didn't know that, couldn't
Right.
remember that much about them. So that's what I've gone on to now. And yeah, so like here's my sort of decision tree, which has only got bits
Right.
of pieces or whatever,
Right.
and it works its way
Yeah.
down. And yeah,
So
like then,
do you know what n estimators is now? Or
well, what is? Oh,
Yeah, basically, if I can jump in, Jack, is the number of estimators is like the and the leaves, right? And when Steve only provided the number of estimators, it uses a default number of leaves. So the number of estimators, if I recall, and Steve can correct me, is the thing, the splits that it decides to make, I think, of depending on how many variables it chooses. And then the leaves are, yeah, that picture can give you the better understanding of the leaves and estimators.
And so such models, they don't have parameters like neural networks, right?
well, yeah, so like this is a picture of a decision tree, and you can see here it's only got 4 leaves, which yeah, so I think it's like these things at the bottom of the 4 leaves. So the decision tree, it's looking at each of the parameters that you have in your table. So yeah, I added extra parameters in. So like this is like the log return moving average over 100 time steps. So like it tries to sort of find a value within that, which would let it split so that it would get sort of the best score or whatever for that decision. And yeah, so like it tries to get like this, that's like the mean squared error or whatever. It tries to get that as low as possible by looking at each of its columns and finding where it can sort of put one like if else split statement on that column. And so yeah, so the first one it makes is log return. It finds like it can reduce the error the lowest by splitting here at 0 or whatever. And then so like it makes its next decision and its next decision, and so like it ends up with 4 leaves because like that's what I specified, and then it stops. So like this is obviously like a really small tree. But yeah, so
yeah, and you can decide, or you can provide the forest is then a combination of such trees, and even for the tree you can kind of tell it to use all the parameters or a random subset of parameters or parameters which help you achieve the best, like MSE or the best. There's another, I think, Gini coefficient or other scoring metrics that based on which you split. And all those techniques are what enable the underlie, I should say, the trees, decision tree thing, and then random forest is just a matter of combining those trees in a variety of ways in order to eliminate the overfitting that happens when you use just a single tree. And then when you combine the trees, then you get a forest. And the ways you can combine trees, there are various ways you can combine trees from which you get the forest. And then the forest, therefore, is, think of it as, like ensembling of trees. An ensemble of trees is called a forest. And then that helps you reduce the error of your predictions.
Yes, like each tree it chooses a different subset of your training data to train on. And so like by doing that, it sort of reduces the error by averaging over them all. And this graph, so like this graph here on the bottom here, like this is the number of trees, and like this is the error. So you can see as the number of trees increases, it eventually gets up to about 30 trees or whatever that it thinks is the lowest error.
And the number of estimators is probably the number of trees that you're using then.
Yeah, I think
would
that's
be my
maybe
guess.
I think that's maybe the maximum number of trees or whatever. So
Right.
yeah, I can't remember. But yeah, like anyway, so like it was sort of reducing it down, and there's another notebook. Yeah, so again, just working my way through that chapter, there was a thing about sort of like using different features. So like there's this notebook here, which like describes how to put like sort of, so you've got your basic features which are in the original training set, and then yeah, like he adds extra ones in.
Yeah, the
One thing,
shadow, and then there's a whole other bunch, I think, too, right?
yeah, so there's moving averages and like logs and stuff, but the one that I found interesting, which I hadn't seen before, was like this time feature thing. So like obviously you've got your timestamp, which you can turn into like a normal time, and then you can split your time up into like minutes and days and years or whatever. I'd never seen before. Perhaps you've seen it, yeah, like using like the sign and the cos of the times.
Yeah, no,
like,
I haven't seen it, but what this reminds me, because in a different context, I was going through, the transformers in language modeling.
yeah.
And what's fascinating about what you just showed is the way that the attention is all you need paper models, the location of words, the position embedding that it provides.
Yeah.
To the that attention is all you need paper, the position embedding that they provide is by using a sine and a cosine combination to predict, not predict, but to encode the position. So this seems to be doing something very similar. That's fascinating that it works, but it kind of echoes, right? Because basically there they are trying to predict the position of a word and encode it into the attention mechanism, because attention by itself is agnostic or indifferent to position. So the position encoding of attention in the attention is all you need paper is done using a combination of sine and cosine waves, which is exactly this method.
Yeah. Yeah, like here he was using it because of the fact, obviously, if you've got like 60 seconds in a minute, once you get to 60, the next step is back to 0 or whatever. And if you just use the pure values, then there's no sort of description of the relationship between 60 and 0. Whereas like by using like a sine wave, by taking the sine of it or whatever, when you get up here, if like this is 60 seconds, then it's the same as over here. It's got the same magnitude as at 0. And obviously because of the fact that you've got two values with the same thing which are far apart, so like that's why they use the sine and the cos. So it's like the two values together. Yes, like for here, for 0 seconds, you would have like this value of the cosine and this value of the sine. And so you
so by combining them, are you saying that he makes sure that within the period, he ensures that every value is still unique, whereas that wouldn't be the case if you used one or the other only.
Exactly,
is that
yeah.
the intuition?
Yeah, that's it. Yeah.
Okay.
Yeah, so cool. Effectively, you've sort of got like an X and a Y coordinate for each time point or whatever, but the time points that are close together have the same magnitude.
Cool.
So
very
yeah.
Cool. Hey, if you can post this link, that would be awesome.
Yeah, no, like I thought I'd never seen it before, and I thought it was like a clever way to handle it. So
yeah, and it's actually it's kind of, to me, very timely because I was just looking at how they did this in the NLP domain, and this kind of gives a intuition from another domain that will be helpful in that as well, right? Because they do the exact same thing for position embedding, and I was kind of curious why they combined sine and cosine, and I just got the answer.
Yeah. Yeah, so like after I'd done all of that anyway, I ended up like with all of these features now. So I've got like a load more extra features. But like using the decision tree thing, you can get like these graphs out of it, which show the sort of the relative importance of each feature towards the final prediction. And so, yeah, so it's like saying that these bottom ones here, these moving averages, like contribute like a lot more than the dollar ones that he'd worked out in some of like the normal predictions. So yeah, so like I just took those and like dropped the insignificant ones, and you can draw graphs and stuff to show which are significant. Yeah, so like that's pretty much where I'm up to.
The pre-interpreter graph that you have up there is very useful too, because it kind of tells you the build-up of the to your results, right? Like the one that you had a little bit further up, like each one, how much does it contribute to the, that one, the one that you just went by.
That one?
Yeah, that one. That's kind of cool too, that you can kind of figure out, you know, like how much each of the things is contributing to where you end up.
Yeah, so like these plots are sort of all coming out of, I think it's all out of Fast AI's library or whatever, because like there was that one.
Right.
This one here is like the decision tree. It shows how many decisions have been made to get to things, and then you can like drop off some of these features. Some features, when they're tied together like this, they're sort of saying that both of them are contributing equally or whatever, so you should be able to drop one of them. And so like with that, yeah, like I ended up dropping from whatever I had 34 features down and back down to 12. And then also as well on the thing, you can train it like a multiple number of times. Originally, like I was like training like my random forest thing for, what was it, 400,000 training samples, and it was taking quite a while. Whereas so I started like reducing the size of the training set, and eventually I found like this graph here where the sort of the best results I was getting was on only 3,500. So yeah, like now I've got it that I only train for like that number of training samples prior to the current sort of point that you're trying to predict. And yeah, like it means it goes really quickly. So like as I get a new timestamp from the test data, I add that onto my training set, but I only train for the previous 3,500. I'm not sure if like this value here is significant to the 3,750 we use. I'm not sure. Is it anything to do with that? But it's in a sort of similar ballpark. But yeah, so like it lets you train very quickly because of that.
Right. Yeah, because you know otherwise in fact, when I get to my part, I'll talk about how I'm just stymied by the size of the data because we run out of memory all the time.
Yeah, so I had exactly the same problem. Like this week, my computer was crashing all the time because of the fact that like once I'd loaded in the full thing and stuff. So yeah, like now I've cut down. I only use very recent data. I've dropped all the early data. But anyway, that's where I am, and I haven't actually submitted with any of this yet. And I don't know, like, is it going to work or not? I was just sort of getting up to speed on these, but like hopefully by having like the extra features and whatever, it will help me. So
cool. Yeah, that's awesome though. I think I think that's a lot of progress because basically, you know, understanding and I think the best thing is how you figured out that you can cut down the data size, because I'll get to it when I speak of mine, but I was just totally stuck. In fact, all of last week I just tried all different ways to get around the memory problem and failed. So it's kind of refreshing to see that you don't need all that data.
Yeah.
Jack, any luck?
So I don't really have like a lot of positive results to report. I managed to get the submission to work finally, and I also started training using the whole data set. Like I think one of the things I modified the code for was to do the model checkpointing before the more frequently before the end of each epoch, because since each epoch takes so long. So I just set it so that I would do the validation maybe like a quarter of an epoch and then do a model checkpointing. Yeah, so so I've tried two experiments. One, so let's see. So this is like the mean absolute error for the training set, and the gray line is when the number of context points is 128. So like to make each prediction, you encode the previous 128 timestamps. And the purple line is when there are only 64 context points. So like you only take into account like half of the previous timestamps. Yeah, some of these, yeah, so as you see, the training matrix and losses are logged like over each time step. I mean, each training step, so each mini batch. But for the validation matrix and losses, I've only managed to get a couple of points because there are many training steps to go through before validation takes place. So yeah, so far I've only got like three validations done for this experiment, for example. And for this one, I've only got, I mean, there are only 2 validations that's happened. So I guess the metric I'm tracking to do the model checkpointing is the mean squared error, which is the one that the authors use in their experiments. And you can see like with these 3 validation points, it's increased slightly. Yeah. Anyway, so I've used the gray lines experiments to make a successful submission, and the score I got was this, and it's positive. But so before, when I was debugging the submission notebook, I tried to submit just using uniformly sampled values between -1 and 1. And when I was doing that, the highest score I got was actually this. So it's actually like a higher score than the highest score that I got like using a trained model. Yeah, I think that's yeah, that's sort of what I've been up to this past week.
What did you have to do to get it to submit right? Did you find out what was causing the problem?
To be honest, I wish I knew. I kind of just deconstructed everything. I just well, I don't use that package's definitions, and because I knew what I needed to feed into the model, so I just used those.
Right.
And then just like coded very carefully, and yeah, and step by step. Yeah, and it worked. So yeah, sorry, I wish I knew. Oh yeah, so my submission, I think it completes in about 4 hours. So yeah, so maybe I could add a few more features or increase the number of context points.
Did you not find those, sorry, from those graphs that having a lower number of context points give you better results?
But yeah, so yeah, from those two experiments, yeah, it does seem like having a lower number of context points gives me a smaller loss. Yeah, so the reason I tried like a smaller context point is because I was thinking, because I heard someone mention that this data set is highly non-stationary, so maybe like it doesn't really matter, like, you know, having to look back too many times steps, right? But I'm not sure if that's very good reasoning or not. But anyway, I just tried. I just half the number of context points and see what happened.
Yeah.
Yeah.
Okay. Share my screen. Let me know when you can see it.
Yep.
Okay, so I found this PyTorch forecasting library. Or actually, I started with what Steve had posted last time, and there were like 4 methods. One of them using, I think many of them, if not all of them, using the deep learning techniques for prediction. And then I found one which does this multivariate, supports multivariates forecasting. So I kind of picked that one, which is, I think, the temporal fusion transformer. So I found that PyTorch forecasting has a notebook example that kind of uses the temporal fusion transformer. So I thought, wow, multivariate. And I wasn't, I still have not done all the work that Steve had done to go from the cost to the target. But I said, just to see the thing working, let me just use this and predict the cost. And use the validation, knowing fully well that, there's data leakage and stuff, but use the kind of use training until the 3 months, and then use the last 3 months as validation data. Although technically what I should do, if I can get the method working, is to use training, validation, and then use the last 3 months as more of a test data. But I just wanted to get the method working. So I kind of moved so I kind of, adopted this, and then they show how to get, in fact, this PyTorch forecasting, interestingly, is built very similar to the FastAI approach, but it's built on to utilize PyTorch Lightning, which is just, Lightning is just very similar to FastAI in its approach. So the bottom line is, you first have to convert your data to a time series data set, which has all of these kind of capabilities. And if you kind of go through the tabular support of FastAI, you'll see a lot of similarity to what he's doing. But we don't need a lot of that in this competition, primarily because we don't have the categorical things. Typically, these forecasters used to predict. Time series forecasting is used very much in retail, and if you have retail, then you have all these concepts of holidays and discounts and all this kind of stuff, and even the weather that you can kind of provide in some of these fields. But we don't have to worry about any of that. So I did that, and got, interestingly, after adopting, you can see much of me implementing what is Steve's method of kind of getting rid of some of the data. I had to kind of parse the data to get it in the format. And then much like Steve pointed out, I started off again with some simple high, low, close volume, as well as some upper shadow, lower shadow, and high div low and open sub close, which are very simple definitions of what you could do with the data. And then I kept removing any extra data, also using Steve's code that he shared last week or a couple of weeks back. But what's disappointing is after loading it, and you can convert it into this time series data set, which is kind of cool because all you provide is a timestamp, and then that you can split the data, and then you say target is close, and then you can give it the group ID columns. And then actually this is another thing I have to fix. They use, or at least the method he has shown, uses weight in a different way than what the competition uses, so I have to fix that. But be that as it may, cutting a long story short, I struggled with it all week. The problem was he says start with a batch size of somewhere between 32 and 128. I started with 128, did runs, and now I'm down to 8, and it's still, as you can see, fails because it just tries to use too much memory. And this is after I had already chopped the data to only use first I started with using data for training from the first of the year 2020 through the June of 2021, and then used 3 months of predictions. That didn't work. So I dropped the training data to only use training data from 2021, January to June, and then predict 3 months. That didn't work either. So I said, forget it. I'll try and predict 1 month and use 6 months of data. And after that, that didn't work either. And then I started reducing batch size. That didn't work either. So I'm now, I think I might go in the direction of what Steve pointed out. If it's about, 3,000 points or whatever, then that gives me a hint. Maybe I don't need all that much, and I just need whatever data points happen to be in that window that Steve is pointing of. His thing seems to suggest, which is 3,000 data points, and see whether I get anywhere getting that to work, because everything I attempted, I was able to load. And then, interestingly, similar to what Steve's AR model showed, he tries to calculate a mean absolute error for a very baseline model, which just copies exactly what Steve was saying, which just copies the previous data, and then tries to say, this is the score, this kind of a baseline score. And if I could get my model working, then see whether I can come up with a score which is better than this baseline. So that's what I spent my time doing last week and failed at that too. So now, given what Steve just shared, I might chop the size of my training and see whether I get any results worth noticing. But it's kind of cool that the PyTorch forecasting thing allows you to just import these models, many of the deep learning models, very quickly once you get the data all loaded up. And it's kind of very insightful to just go through even what all these fields mean in this definition, not that one, that one. And you can kind of go through every one of these fields and see what they mean. And here's examples here of some of the stuff that you can do. And this is, I think it's very powerful tech capability, especially in not necessarily in what we're doing right now, but in many of the competitions that you actually encounter in time series, which is much more oriented towards predicting prices and product SKUs and things like that, that many Kaggle competitions have. And the other cool thing, for example, sorry, go ahead.
Yeah, so can you say what encoder length and what prediction length you're currently using?
I'm actually, the encoder length I'm using is the length of my training set, right? So it goes from, right now, what I was trying was from January 2020 to June 2020, 2020, sorry, January 2021 to 1/1/21 to 6/20/21. And then I was trying.
Yeah, because I'm just wondering if the encoder length has the same meaning as like my context points, then my encoder length is just 128 minutes. And so if your encoder length is like the entire data set, then yeah, I don't see how it could fit into the memory.
Yeah, so that's where I have to I'll have to see, but see what he says here clearly is the maximum history length used by the time series data set. That's the encoder length. And sorry, I misspoke. My encoder length right now, as I have it in my current notebook, is from 1st of January 2021 to 20th of August 2021, because I finally broke down and I was just predicting the last month using the 8 months previous. But what I could do now, based on what Steve is saying, is, calculate whatever 3,000 points, 3,000, was it 3,000 time steps, Steve?
Yeah.
Okay.
Well, it was actually 3,500, but yeah, like when you're using a transformer like this, perhaps you might have to knock it right down to like what Jack said, like down to 128 or something. I'm not sure.
Because I think like the model size scales as the square of the encoder or decoder length. So yeah, the model size also increases.
Are there many examples on this PyTorch forecasting website? Do they have, like within the tutorials and stuff, do they have any tutorials that predict on stock prices?
Yeah, in fact, this how to use custom data, he uses Kaggle competition, different Kaggle competition to illustrate. That's kind of what I was doing with this too. Was it this? Did I miss that? I think this one, for example, is I've just been focusing on this particular example, but there may be other examples too, because he also has one that uses NBeats, which I didn't focus on. I focused on this one, the temporal fusion one, primarily because it's a multivariate thing. So it predicts all of the different coins thing at once. Whereas NBeats and stuff, you'd have to do this coin by coin. So that's why I chose to focus on this one. But he obviously has at least a couple of different examples, maybe more too. So you can see, was it here, or maybe I closed the.
Yeah, can you tell sort of what size of training data he's using in these examples? Is it?
He's using very small one, but then, like exactly to a point, I think that Jack was making as well. He uses in the example that I was following along, which this is not the one. This is time series data stuff. This is not the one either. I think I closed by mistake. Rather than wasting your time, I'll post the link if I can figure. This is maybe the one that. That's also he has some different example, and on that particular one that I was focusing on, he had used 128 as, I think, the encoder length. And he was saying, though, in the write-up that the bigger the model, that there was, and he was using about 2,000 time steps, if you will. And he was saying that's very 2,000 or 20,000, I forget now. I'll have to check. That's very small amount of data for this model. The model is very powerful, and the more data you provide, the easier it is for the model. The performance of the model is much better with a lot more data because it's very powerful. So, go ahead, Steve.
Are there two settings? Or is there a sort of like setting for the amount of training data you use, and then a setting for sort of the time window that it uses to look across that data?
I didn't see that because see here, the max encoder length is the maximum history length used by the time series data set, right?
Yeah.
And then the max prediction length is the max prediction or decoder length. And the prediction is basic, and what you provide as input to, I wish I could find that. Let's see the tutorials. Yeah. Okay, this is the one. Yep. So see here is using the Stallion dataset from Kaggle, which apparently is an attempt to forecast SKUs of beverages in various stores, if you will, and also has the date, time, and then because it's a store, it has things like weather and holidays and stuff like that would have an impact on your predictions. And see here, he is to make a 6-month forecast, right? And there are about 21,000 monthly historic sales records, 21K, not 2K as I was saying, 21K. But even that, he says, is small for the data.
The 21,000 is
for
not
the
the
model.
encoding length though, right?
Yeah, that's correct. See, he uses max encoder length of 24 only. And then max prediction length is 6. Right? Because he's predicting for 6 months.
Yeah, so his 21,000 is the length of the time series data set, isn't it? But yeah, like then he's just using 24 encoding points across that.
So it's to predict the next 6 months based on the previous 24 months. Is that what this means?
Yeah, it might have to. But then see, yeah.
Did you have your max encoder length set to whatever, several thousand?
I calculated, you're right. I calculated the length of the time steps input. That might be the problem. Why it's crashing with the memory stuff. Yeah. That's a good point. So I need to play with this to see whether I can get that thing.
Yeah, it looks good though. Like,
and then
it's got all the stuff in there. So.
Yeah, that's what I found interesting is, it's able to do, and then if you can get it to train, and then he's kind of, very similar to the FastAI, I think, find the optimal training rate, right? The learning rate or the learning rate, and then you just train the model. And then what's also cool, and this is the hyperparameter tuning, some of the stuff that you can do. And you can use, like you're saying, Steve, the features you want to provide, you can kind of play with that independently of all this, right? I just started with these 4 features plus the cost things, but you could kind of do that independently, and then you can evaluate the performance as well, which he shows, and he kind of shows the observed predicted, and you can kind of plot that. And the other cool thing he talks about is this gray things, which, you know, besides this particular last 6 months that he's predicting, he talks about how yeah, you can this is the other cool thing which I thought was very interesting, is the gray line denote the amount of attention the model pays to different points in time when making the prediction. And this is apparently a feature of the temporal fusion transformer. So what you are actually seeing here is when it is predicting this, much like in case of the NLP transformer usage, where, you know, you've we have seen in our NLP course the couple of blog posts that show the various heads, what they're paying attention to in terms of the words when they're predicting the future. So similarly, this gray plot apparently tells you what are the points backwards in time that the temporal fusion transformer is paying attention to when it's predicting this, which I thought was interesting.
So it's important when it drops. That's what it says, right? So
Sorry,
it seems to be paying more. It seems to be paying more attention whenever it drops in the past. I think that's because whenever the gray line goes up,
right,
the blue line goes down.
Right. Yeah. I don't know whether that's consistent. Yeah, when it goes up, it goes down. When it's down, it kind of seems to be somewhat a mirror image of the blue line, is what you're saying, right?
Yeah, I guess.
But that could be just change too, right? Whenever it's changing, it's kind of getting higher.
Yeah.
Right? Whenever it detects a change. I wonder what it would be if it's flat. Like here, it's most flat. Here. Yeah, I thought that was kind of interesting thing as well in this technique, that you can kind of plot this and stare at it and see whether you can draw some insights. Yeah, see here, right? It's flat when it's constantly going up.
Yeah.
Right? And here also it's pretty much flat when it's in kind of like a limited range, if you will. It's flat, this is flat. But it's also flat when there's a constant rate of increase. So anyway, I just thought this seems to be handy, quick, related modern technique. I can't, that's where, you know, once this thing is over, maybe we can spend some time kind of understanding these models, like what does temporal fusion transformer do and what does the paper talk about?
And do you think if you get it working, does it take a long time to train?
I would think, did he say something about, yeah, here, he talks about that here. He says that larger networks can take hours, but this thing he ran took only a couple of minutes for 20,000 points.
Yeah.
So he's training on CPU? Or,
yeah,
like, can you train on
training just on his MacBook? So I would assume that it's just on his, I don't think.
Well, it says there in the line above.
Sorry.
You can see, like in the line above, it says it doesn't have a GPU or a TPU. So
yeah, false.
Box,
yep.
Yeah.
Right. Yeah.
That sounds a bit surprising, to be honest.
I know, yeah. No, what I was wondering
So
was,
it's able to train. Go ahead, Steve.
yeah, I was just wondering, yeah, so like if you did get it working, would it be able to work with the fact that you have new data coming in at each time step? Can you add that into the predictions, or will it just be like a model that you have to train up front and then like a model that would just be used to predict for the entire competition as opposed to one that gets retrained as new data arrives?
That is a good point. I haven't looked at it from that standpoint.
So at the moment, mine is just upfront. But,
yeah.
But you know how I mentioned like my submission currently only takes about 4 hours. So technically there's room there to do some training, but I think I'll pass on that one. It's probably too complicated for me. Yeah.
I was wondering as well, do you think that your predictions get progressively worse with time?
Yeah, it's likely.
Yeah.
Yeah, I think your approach, Steve, is the best, which is to definitely. So I'll poke at this some more to see whether you can kind of. I didn't spend too much time thinking. About that particular problem. I just wanted to see this thing working, and then I was wondering, yeah, whether you could do this 16 steps at a time kind of approach, right?
Yeah.
Because if you can do that and combine it with this, then it seems like it would be a pretty handy thing to pull off.
Yeah, no, like it looks cool, like if you can get it working. So
yeah.
Like,
you know,
I probably would have tried this library first if I had known that existed.
yeah.
Yeah, no, Steve's blog posting turned me on to temporal fusion transformer, and from there somehow I jumped to this PyTorch forecasting library, which seems pretty handy. And then, you know, that combination is what I started to focus. But I think Steve's question is a good one. Plus, both of your observations that I should just read the length to be the 128 or something in that range, and then try with it and see whether it works, and then focus on what Steve asked, which is, hey, can I somehow focus 16, and I'm just going to do it with the cost thing right now to get that working, and see whether I can predict cost 16 time steps at a time to go for like a month, which would be 2 sets of prediction. Right?
When you say cost, you mean like the closing prices, do you, or do you mean the target?
Closing. Closing. Yeah, closing.
Yeah.
Cost.
Yeah, the notebook had showed like the really simple one that was using like the boosting algorithm. It was just predicting directly on the target. So I don't know if you could do that, because it keeps it really simple then, because it means you just take the data that you're given and you just predict the target, and you don't have to worry about closing prices or the 3,750. Yeah, like I'll share a link with that simple notebook, and you could maybe just replace his boost algorithm with this thing, just to see how it gets on.
Yeah.
Because like there's a lot less fiddling about then.
Yes. It's a good idea.
Yeah, because my strategies become really complex. It's like, yeah, I'm having to predict sort of 16 closing prices and price ratios, and then take it back over to 3,750 and stick it through the formula to try and get the target, and it's become a nightmare. Whereas, yeah, in retrospect, it may be a good idea just to go straight to the target.
Yeah, that's a good thought. Let me try that too, because there's no reason I can think of why it shouldn't just directly go to the target, because we have the target, and it also has this cool thing within the time series data set. If you dive into it, you can tell it that you have missing time steps. So it knows that there is, in fact, strangely enough, while I was fiddling with it, I tried in the data set itself, I had some of my settings wrong, and it then came back and told me, you can't use these settings because you have missing time steps. So the time series data set is smart enough that it kind of knows if certain flags are in set, and it goes through the data set. And, it's very similar to that FastAI in this thing, that FastAI spends a lot of time kind of prepping the data And then once you have the data into the format, then this learner thing is very easy to do. And he takes a very similar approach and builds it off of. So you can run it on top of this PyTorch Lightning thing, which is very similar to FastAI without a lot of the details or underlying mods that FastAI does. So yeah, that's a good suggestion, Steve. I'll try it with directly with the target too.
Yep.
Cool. So that's kind of what I spent my time trying last week. Hopefully this week I can get it running.
So like looking at the competition, I think there's only 10 days to go.
Yeah.
And
I know.
yeah, it says 3 days until merger deadline, but I don't think we've got anything to merge. So
yeah, exactly. It's more like, to me, it's like get the simple things, and much like you did last week of understanding the like GBM, and get the time series concepts working, because it just seems otherwise to be, unfortunately, it made it a little too complicated for stuff. I'm wondering, based on what you shared earlier, Steve, of whether anybody really has anything of value from the notebooks that they are going to get as winners and stuff, because there are all these complexities to deal with of, some coins might drop. You have to integrate the basic data with the incremental data between October or whatever to the in between time, that from when the competition started to when it is actually going to start. All these kinds of things that people have to take into account to get the notebooks to work correctly with their API going forward.
yeah, like as I said last week, I think that anybody who can get like a notebook that manages to make it all the way through to the end of the testing session is probably likely to sort of be in with a good chance of getting a medal out of it.
Yeah, I would be so gutted if mine just crashes straight away. It's like a paper plane, like nose diving, like soon when you release it.
Yeah, so like I had like a really simple notebook that just predicted like the median value, and it got like a positive result, and it got like a sort of positive result, sort of better than anything I've tried with complex time series. So if you get to like do 2 submissions, I might just put one in like that, one which just predicts the median, but just is really simple.
Yeah,
one that's guaranteed to sort of make it all the way through.
Yeah, so I just backed off from the competition thing and said, okay, let me just benefit from doing some of this by understanding and trying some basic thing. But I think few of your suggestions are very useful, so I'll try those in the next few days.
Yeah, like certainly, like although I haven't come up with any notebooks that are going to win the competition or get anywhere close, I've learned a lot about time series modelings and now about decision trees and stuff. So yeah, I've learned a lot out of it. But...
yeah, that's where I'm at too. I think I had no idea about the whole ARIMA world and SARIMA and all of that kind of stuff, and what's needed in order to prepare data for time series, and then some of these deep learning techniques that are just coming into vogue, and then this PyTorch forecasting thing. So I think a lot of that is useful, even more than just the competition stuff, which I think they should have simplified it somewhat in my assessment if they wanted meaningful contribution. Much like the, I think, Steve, we spent a lot of time preparing data, or you did specifically on the previous, lung thing competition, but at least the evaluation and other thing wasn't too complicated. So once the data prep was done, it was pretty straightforward. But this one, it has too many bend, twists, and turns to get to the end point, I think. Okay, thanks, folks, for joining. And it was very, at least for me, it was productive since I got some excellent suggestions to try in the next several days. And
okay, good luck getting that working.
Yeah.
Yeah, good luck.
Hope so.
Thanks.
Okay.
You guys posted. Thanks a lot.
Okay.
Cheers.
Speak to you next week. Cheers. Bye.